Welcome back to the deep dive. Today we're stripping away some of the jargon and looking at something that definitely keeps CIOs up at night, even if it sounds a little mundane on paper. We're talking Azure storage security.
Yeah.
And I don't want to frame this as just, checking boxes for compliance.
No, absolutely not. We are talking about the crown jewels here.
Yeah.
I mean, in a modern cloud architecture, storage isn't just some passive archive anymore.
Right.
It's where the PII lives. It's financial records, it's intellectual property, your ML models. If this data gets compromised, the game it's pretty much over.
Exactly. And the scenario we're looking at today places you, the listener, right in the hot seat. You're the gatekeeper. And your mission is, well, it's kind of a paradox.
Mm-hmm.
You have to lock this data down so tight that no unauthorized person can even look at it. But at the same time, you have to make sure every legitimate app, every developer, can get what they need instantly.
That is the classic friction of cybersecurity. It's availability versus confidentiality. I mean, if you secure a storage account by just pulling the network cable, you have perfect security.
Yeah.
And zero utility.
Right. It's a very expensive brick.
Exactly. So the challenge and what we're digging into in the source material is how you architect a solution that balances those needs with the tools Microsoft gives you.
And the framework for that, which the sources point to right away, is defense in depth.
Right. This is the foundational philosophy. It completely rejects that old hard outer shell, soft, chewy center model where you just, stick a firewall in front and hope for the best.
I always like to visualize it physically. You've got your data, right? That's the core.
Yep.
And around that is the application layer, then compute, network, perimeter, identity, and finally the actual physical security. It's not just a lock on the front door.
No. It's a gate, it's a guard, a badge reader at the elevator, and a biometric scanner on the vault itself. If an attacker breaches one layer, say, they get past your network firewall.
They shouldn't just own the data.
They shouldn't. The next layer, identity and access, should immediately step in and say, okay, you're on the network, but who are you?
So let's open up that toolbox. The sources basically categorize the main controls into 3 buckets. We've got encryption, authentication, and authorization.
The big 3. Encryption is about confidentiality, making the data unreadable. Authentication is the who proving you are who you say you are, and authorization is the what you're allowed to do.
Let's drill into authorization first. This is where I feel like I see the most confusion out in the wild. The sources lay out 3 main strategies for letting people in. The first one, and it's clearly the preferred one, is Microsoft Entra ID.
Yeah, formerly Azure Active Directory. This is the gold standard now. It all uses role-based access control, or RBAC.
Which means we're not managing access with, individual file passwords. We're managing identities.
Correct. You're giving permissions to a user or a group or an application's identity. You can say the billing app has read-only access to the invoices container. It's super granular, it's auditable, and you're not passing hard-coded keys around.
But then we have the old giant in the room, the shared key.
The shared key. This is the easy button, but it is so dangerous.
It's the root password problem, isn't it?
It is exactly that. When you create a storage account, Azure generates 2 512-bit storage account keys. If you have that string of characters, you have full admin control. Full stop.
You can do anything. Read, write, delete.
Change configurations, everything.
And the operational risk there is just massive. If I'm a developer and I hard code that key into an application and that somehow gets pushed to a public repo,
You're compromised.
instantly.
And the remediation is so painful, you have to rotate the keys, right? Regenerate them in the Azure portal.
And the second you do that,
Everything breaks. Every single application using that old key just stops working until you update it. It's an operational nightmare.
Okay, so Entra ID is the goal. Shared keys are the big risk we want to avoid. But there's this middle ground that our source material spends a lot of time on, the shared access signature, or SAS.
The SAS is the bridge. It solves a very specific problem. How do I grant granular temporary access to something without giving away the master key or creating a whole Entra ID account for, say, a temporary user?
The best analogy I've heard is the hotel key card. The shared key is the master skeleton key for the whole hotel. You'd never give that to a guest.
Never.
You give them a key card, the SS, that only opens room 204 and only between 3 p.m. Tuesday and 11 a.m. Wednesday.
That's it. It's a URI, a link that delegates access, but you can program it with incredible specificity.
Now, the sources break down a few types of SAS. There's a user delegation SAS, a service level, and an account level.
And that distinction is important. A user delegation SaaS is actually backed by Microsoft Entra ID. It's the most secure type because it doesn't even touch that dangerous shared key we were just talking about.
So it's checking my Entra permissions first before it even issues the token.
Exactly. Then you have the service level SaaS for specific things like one single blob, and the account level SaaS, which is much broader. It can even do admin-like operations.
Okay, but here's the catch. A SaaS is a bearer token,
Yes.
which means if I generate a SaaS link for a sensitive file and I email it to you, but a hacker intercepts that email.
The hacker has the file. The storage service doesn't care who is holding the token. It only cares that the token is valid.
So we need defense in depth for the SaaS itself. The sources list a bunch of best practices. First one seems obvious. HTTPS only.
Mandatory. Non-negotiable. If you send a SaaS over HTTP, it's just plain text. Anyone sniffing the network can grab it. Enforcing HTTPS encrypts the channel. It's that simple.
And then least privileged.
Don't get lazy with this. If someone only needs to upload a file, you give them right permission. Not read, not delete. You limit the blast radius from the start.
Okay, now this next one is my favorite because it's the panic button scenario. Stored access policies.
This is a total pro tip. This really separates the amateurs from the experts.
Walk us through it. Why is it so critical?
Okay, so let's say you issue a SaaS URL that's good for 30 days. 2 days in, you realize that token has been leaked. How do you stop it?
With a standalone SaaS,
Yeah.
I can't. Not without rotating the entire account key, which we just said breaks everything else.
Exactly. But with the stored access policy, you define the permissions and the expiry time on the server, on the container itself, and you just link your SaaS to that policy.
So the SaaS doesn't contain the rules. It just points to the policy that has the rules.
Right. So if that token leaks, you just go to the container, you find the policy, you change the expiry date to yesterday.
Oh,
Just delete it. Boom. Instantly. Every single SaaS linked to it is invalid. It gives you a revocation switch.
That's a huge operational win. Now, there's another gotcha in the sources that I think trips up a lot of people, the issue of clock skew.
Ah, yes. The fact that time is not absolute in distributed systems.
We just assume that 12 o'clock is 12 o'clock everywhere.
But in the cloud, with thousands of servers, there are tiny drifts. If you generate a SaaS token with a start time of right now, and the server that gets the request thinks it's actually 30 seconds before now, it's going to reject your token.
It says, sorry, you're from the future, access denied.
Basically, yeah. And it causes these awful intermittent failures that are impossible to debug. So the recommendation is just practical. Backdate the start time. Set it to 15 minutes in the past. It's a buffer that accounts for clock drift.
Such a simple fix. Okay, let's talk about the anatomy of this thing, the SSURI. To the untrained eye, it's just this long string of garbage at the end of a URL.
But it's really contract. Every little parameter controls something. You've got the resource URI, the address. You have STIN/CEF for the start and expiry times. SP for permissions -R, WFUD for read, write, delete.
And SIP, that's for IP restrictions, right?
Correct. You can lock that token down so it only works if the request comes for your corporate IP range. But the most critical piece, the part that actually makes it secure, is the SIG, the signature.
It's a cryptographic proof.
It's an HMAC. Basically, Azure takes all those other parameters, the time, the permissions, all of it, and signs them using that secret storage account key.
So if a hacker gets a valid URL that has read permission and they just try to manually edit the string to say write,
The signature is immediately invalid. The math doesn't check out. The storage service recalculates the hash on its end, sees it doesn't match the signature you provided, and just drops the connection. You cannot tamper with it.
that makes perfect sense.
Yeah.
Okay, so we've covered how we let people in. Now let's talk about protecting the data itself. Encryption. The sources say Azure storage encryption is just on by default now.
It is. This is that data layer defense. Data at rest is protected by Storage Service Encryption, SSE, using 256-bit AES. It's totally transparent. Encryption happens when you write, decryption when you read. You don't even notice it.
And for data in transit.
HTTPS, which we
Yeah.
covered. But also for Azure files, it enforces SMB 3.0, which has built-in encryption for data moving between your machine and the file share.
Now, the big debate is always key management. By default, it's platform-managed keys, PMK, Microsoft handles everything.
That's the easy button. Microsoft generates, rotates, stores the keys. For, I'd say, 90% of use cases, that's perfectly fine.
But for that other 10%, the banks, the government agencies, that's not going to fly. They need customer-managed keys or CMK.
Right. This is all about data sovereignty. With CMK, you generate the key in your own Azure Key Vault. You control its lifecycle. You control its rotation policy.
And critically, you control the kill switch.
That's the ultimate safeguard. If you suspect a total compromise or you get a subpoena you need to contest, you can just revoke the storage account's access to that key in your key vault. The data is still there, but it's encrypted with a key that can't be accessed. So it's just digital garbage. Not even Microsoft can read it.
But that's a huge responsibility. If you lose that key,
The data is gone forever. There is no forgot my password link for customer-managed keys. It's a high-risk, high-reward setup.
and the sources mention bring your own key, be okay.
That's just a flavor of CMK, where you generate the key on your own hardware security module on-prem and then securely import it into the key vault. It just ensures the key never originated in the cloud.
And for the truly paranoid, there's infrastructure encryption.
I wouldn't call it paranoid, maybe highly regulated. It's double encryption. The data is encrypted once at the service level and then again at the physical hardware level with a totally different key and algorithm. So layers on layers.
Layers on layers. Okay, so we've built the fortress. We have walls, guards, encrypted vaults. But we still need to know if someone's trying to dig a tunnel underneath it all. We need monitoring.
Oversight, yep. You
Yeah.
can't secure what you can't see. And in Azure, the main tool here is Azure Storage Insights, which all feeds into Azure Monitor.
And this is more than just checking if the server is up.
Oh yeah. From a security standpoint, we're looking for anomalies. We're hunting for changes from the baseline.
So what does that look like in the logs? Give me an example.
Okay, so maybe your app normally reads about 10 gigs of data a day, all during business hours. Suddenly, Storage Insights flags a massive spike. 500 gigs are being downloaded at 3 a.m. on a Sunday.
Data exfiltration?
Could be. Or you see a sudden surge in delete blob operations from an IP address that has only ever done reads before. That's an indicator of compromise.
And you can track this because the logging is so detailed.
Yes. The logs give you every request. The ID, the operation, the caller's IP, the user agent.
And this ties right back to our first point about Entra ID. If you're using shared keys, the log just says authenticated with key. It doesn't tell you who.
That is such a critical point. With Entra ID, the log says, user, John Doe from finance. With a shared key, it just says, someone with the key did this. It makes forensics so much harder.
So to bring it all together, we've gone from the master key nightmare to the really fine-grained control of SAS tokens and Entra ID. We've encrypted the data maybe even twice, and we're watching it like a hawk with Storage Insights.
It's a complete ecosystem. And the takeaway really is that security isn't some binary switch you flip. You're not secure or insecure. You're just constantly managing risk through layers.
And making trade-offs.
Always. You trade convenience for control. You trade simplicity for granularity. The goal is to apply the right level of friction to make it impossible for the attacker, but totally seamless for the legitimate user.
Before we wrap, I just want to circle back to that clock skew point. I think it's such a perfect metaphor for all of cloud engineering.
The 15-minute gap.
Yeah.
Yeah.
We spend millions on cryptography and identity, but sometimes the whole system can fail because one server thinks it's 12.00 and another thinks it's 12.01.
It really leaves you with a provocative thought, doesn't it?
Yeah.
In this world of instant global access, we assume the infrastructure is this perfect monolith. It's not. It's a chaotic collection of distributed machines all just trying to agree on what time it is.
So the question to leave with is, are your security policies resilient enough to handle that messiness? Or is your system so brittle that a few seconds of clock drift could bring the whole thing down?
Resiliency isn't just about resisting attackers. It's about resisting the natural entropy of the universe.
A deep thought to end a deep dive. Thank you for walking us through all these layers today.
My pleasure.
And to our listeners, go rotate your keys, audit your SAS policies, and maybe set your clocks back 15 minutes, just to be safe. We'll see you on the next one.